This is Mr. Ashton going through the Mathematics Unit 2 Calculator Allowed intermediate paper from the summer of 2018. Okay, so the first page has got our formula list that we might need to come back to and check at some point, and then the very first page then to do question on said blank page. So it wasn't until actual page 4 that we had question 1. Okay, so the first question says solve x over 4 equals 7, so that's solving an equation. So to solve an equation, what I need to do is get the letter by itself, in this case the x by itself, and to do that I need to unlock whatever's being done this side. So what I need to do to unlock a divide by 4, or to do the inverse operation of a divide by 4, is I need to times by 4. Now to keep that balanced, I need to do the same thing to the other side. And then x divided by 4 times by 4 will leave me with just x here. The equals to stay in a nice neat line. And then 7 times by 4 will be 28. Okay, and that's a very easy way to check if that's right. What's 28 in place of x? We're saying x is equal to 28. What's 28 divided by 4? The answer is 7, so we know we're right. Okay, the next question, part B, says simplify 3f. So I'm going to just underline anything with an f in it. I'm going to underline anything else with an f in it. So I've got a plus f there. 3f plus an f, that's effectively a 1f, just by itself. 3 plus 1 is 4. That'd be 4f's, and then we've got plus 7g, and then we want to take away 4g. So I'm going to get plus 3g. Okay. Question underneath, C says use the formula 5p plus 2q equals t to find the value of q when p equals 4 and t equals 24.6. So this might be the first time we actually used the calculator so far. So I need to find the value of q. So that 2q will stay the same. But what I will have in front of it is I'll have a plus a 5. In fact, actually, let me just try and use my highlighter a bit here. 5 times p, 5p, 5 times p. That's what that means. So that's 4. And t, so nothing times by the t, it's just 24.6. Okay. So what I'll have in front of it is 5 times p, so 5 times 4, and I always write it like that with brackets in it. You don't have to, you can just say 5 times 4, but your calculator will always know what you're doing if you do it this way, is equal to t. Now, because that's not timesing anything, I can just say equals 24.6. Okay, so it's very similar to the question that we did up here, actually, by the time I finished. 5 times 4 is 20, plus 2q is equal to 24.6. Now what I want to do is get the q by itself. So rather like I did before I unlocked the question above there, I said, oh, what's the opposite? Divided by 4 times by 4. I want to do the same sort of thing here. So the first thing I'm going to do to get q by itself is I'm going to get rid of anything not physically attached to it. So I'm going to get rid of that 20. That's a positive 20. If I take away 20, 20 take away 20 will disappear. Whatever I do to one side, I need to do to the other. So I'm going to get here, there's my equals in a nice straight line. 2q is equal to 24.6, take away 20. So still no need to use the calculator yet. 4.6. And now to get the q by itself, I need to divide by 2, because that 2 touching the q means it's timesing by it. So whatever I do to one side, I'll do to the other, and get q is equal to 2.3. Okay. Next question, number 2. It says, the square drawn below has a rotational symmetry of order 4. Now let me just show you what that actually means. If I go and trace this shape here, square, not perfectly, but this is why you get given tracing paper in the exam. If I go and put a little arrow up there, if I spin that round until the arrow is pointing back up, how many times does it fit on itself? So once, twice, 3 times, 4 times. It fits on itself perfectly 4 times. Okay. Now it says place 2 identical dots on the square so that it will have an order of rotational symmetry of 2. So it's got to fit on itself exactly twice. Okay. Now, in order to do that, I'm going to put one in here, and then not there, because I think it'll only fit on itself once if it does that. I'm going to do it directly opposite. So let's check if that's the case. So there's the dot, there's the dot. So if I spin it in the middle, there it's fitted on itself exactly once. Okay, if I keep on spinning it round, it doesn't fit on itself there at all. And then when the arrow is pointing back up again, it fits on itself perfectly once. Okay, so we did it once when the arrow was upside down and once when it was pointing up. So all together, that has given it an order of 2 in terms of rotational symmetry. Okay. Now, in terms of where you could have had those dots, I put them there and there. You could have put them there and there as well. That would have also worked. Part B is very similar. It says a regular hexagon. So a hexagon is a 6-sided shape, and because it's regular, all the sides and all the angles inside will be the same. Now, because of that, because it's a 6-sided shape, you'd expect that to fit on itself 6 times. There we go. It has a rotational symmetry of order 6. Place 3 identical dots on the regular hexagon so that it will fit on itself 3 times. Okay, so I'm looking to get it into 3 places. So I want to go 1, miss 1, 1, miss 1, 1 here. So I think that will do it. So let's check it. Got the tracing paper. Okay, so 1, 2, 3. Arrow pointing up. Spin it round until that arrow is pointing up again. So I'm going to do that in the middle. Now, it doesn't fit on itself there. Dots onto the right places. That's the first time. That's the second time. And then all the way around, that's the third time, okay? Any shape will always have at least order of rotational symmetry of at least 1. Because you always do one whole 360 spin, and that's always going to fit on itself once, no matter what the shape. But certain shapes, like regular hexagons, squares, they're going to have more than the 1. C says, which of the following shapes has rotational symmetry of order 3, but has no line of symmetry? So basically, if I folded it in half, it wouldn't fit on itself. Now, I know that this one here would fit on itself straight away, so I can discard that one straight away. That one there, I can see that, oh, hang on, let me show you can see there. I can see that that wouldn't fit on top of that because it's pointing down. It would point up if it was symmetry. Now, that is exactly the same type of question as this one here. That would fit, so we can discount that one there. That one there wouldn't fit itself. Although the bottoms 2 would, you'd need to have like a square here, so that's got no line symmetry, so that might do it. And then this one here, yeah, they're not both sides. Sorry, they are both sides, and these are both sides, so that has got line symmetry as well, at least there, okay? So we're told to have no line symmetry. This has actually got at least one here, at least one here, at least one here. Actually, if you try to rotate the paper, you probably find it's probably got 3. So we can discount, not that one, sorry, we can discount that one as well. So it's either this one or this one. Okay, well, what I'm going to do now is I'm going to trace my shape. I'm going to put that little arrow, and I want to do one full 360 spin and see if it fits on itself 3 times. So, yes, once, twice, and 3 times. So it's that one. That's my shape. Okay. If you went and did it with this one, you find that it doesn't. Okay. Okay, then over the page, we've got question number 3. Make sure you've read the question. I'll give you a second just to have a quick read. Okay, then it says a travel company offers the following holiday options: time, summer or winter, accommodation, cottage or hotel, transport, train, bus or car. List all the different possible combinations that you can get from the holiday company. One has been done for you. So I could travel in the summertime, I could have a cottage, and I could have the train. Now, the way that I do this is I try and exhaust it. So I try and keep as much the same and just change the last bit here, okay? So I'm going to be fussy and say, well, we could have had the summer, we could have been in a cottage, and instead of getting the train, I could have got the bus. So I've dealt with that one and that one so far. So there's only one other option that I could have got. I could have had a car there as well. So a cottage. And annoyingly, you will have to write all this down, although I'll probably just change it for the rest of the video to just say S, C, and C like that. Now, there's no other way that I could have gone in the summertime, stayed in a cottage, other than had a train, bus, or car. Okay? So the next thing I'm going to look at, I'm going to stick with the summer options, is that I could have gone in the summer, but instead of going to a cottage, I could have gone to a hotel. And I could have got the train. I could have gone in the summer, stayed in a hotel, and got the bus. I could have gone in the summer, stayed in a hotel, and got the car. Okay? So we've got 5 options there just by sticking with the summer and just changing in between the cottage and the hotel and just changing my different sort of modes of transport here. I want to repeat exactly all of the same as these things, rather than going in the summer, as I could have done all of those again, but in the winter. So winter, cottage, train. Winter, cottage, bus. Winter, cottage, car. Similarly, I could have gone the winter, hotel, train. Winter, hotel, bus. Or winter, hotel, car. Okay? Part B, a holiday is chosen at random from the list of different combinations on offer. P is the probability that a holiday chosen is a summer holiday, staying in a cottage, travelling by train. Well, how many combinations have we got which fit that? So summer holiday, so summer, so we're looking up here, staying in the cottage, here, and we're travelling by train. Well, literally just this one here that they gave us originally, out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of 12 different options in total. Okay, so think of this as being 0, and this is 12 out of 12. In the middle would be 6 out of 12. In between 0 and 6 would be 3 out of 12. And then we're looking for just 1 out of 12. So we want to split this little bit into thirds. So 1, 2, 3. So I'm going to make it here. So it's roughly around here somewhere. Okay. Okay, next question. It says, which of the following fractions is nearest to 1/4? 1 over 5, 7 over 25, or 13 out of 50. Now you have a calculator with this, and you could go and just literally stick into your calculator 1 over 4, press equals, SD, and have a look at the decimals and compare decimals. That would be one way. I prefer personally looking at fractions and getting them nearest to it. So what I would be looking for is a denominator where they're all the same. Now they'll always be bigger, or at least as big as the biggest one, okay? So does 5 go into 50? Well, the answer is yes. 5 times 10 is 50. Does 25 go into 50? Yeah. 25 times 2 is 50. But does 4 go into 50? No, there's no number that if I do 50 divided by 4, for example, I get the answer 12.5. So it doesn't go in nicely, okay? If I think of a denominator that these two guys will fit it into, I can guarantee, or more or less guarantee, that these two will fit in with the numbers they will give you in the question. So if I start looking at what numbers 50 goes into, the next one in the 50 times table will be 100. Now 25 definitely goes into 100, 5 definitely goes into 100, 4 into 100, let's check. So 100 divided by 4 goes in 25 times. What I'm going to do is I'm going to change all of the denominators to being over 100. So there's my 1/4, and then 1/5 I'm going to make over 100. I'm going to make 7/25 over 100, and I'm going to make 13/50 over 100. Okay, what do I do to 4 to make it 100? Well, I've just got to work that out in my calculator. I times it by 25. Whatever I do to the bottom, I must do to the top for equivalent fractions, so this would be 25 over 100. So we're looking for the fraction that is closest to 25 over 100. What do I times 5 by to make it 100? Answer is 20. If you're unsure on your calculator, you would do 100 divided by 5. It'll tell you how many times 5 fits into it, 20. 1 times 20 is 20. Okay, so that's 5 off 25. What do I times 25 by to make it 100? Times by 4. Do the same to the top, the numerator, and you would get 28. And then finally, what do I times 50 by to make 100? Times it by 2. Whatever you do to the bottom, do to the top. 13 times by 2 is 26. Which of those answers is closest to, so the quarter, which one's nearest the quarter? So a quarter was 25 over 100. Well, this one is 5 away from 25. This one is 3 away from 25. This one is only 1 away from 25. So my answer is this fraction here, and that fraction was 13 over 50. Okay? Question number 5. Question number 5 says, calculate both the area and the perimeter of a rectangle that measures 6 centimetres long and 4.5 centimetres wide. Use the answer spaces to clearly identify which answer is your area and which answer is your perimeter. You must give correct units for each of your answers. The first thing I'm going to do is actually draw a rectangle. And it doesn't have to actually look perfect, okay? It's just literally just give myself a bit of an idea of what's going on. 6 centimeters long, 4.5 centimeters in width, okay? To work out the area, I would multiply 6 times by 4.5. So I definitely want that to go into my calculator. 6 times by 4.5 gives me an answer of 27. Now, because this is area, we would measure that in centimetres squared, or square centimetres. To work out the perimeter, I'm going to say here that this was area as well. To work out the perimeter, it is one full distance around the rectangle. So if I start here, and I do one full distance around it, until I'm back to where I started from, here. I've gone 4.5 plus 6 plus this distance here, which would be the same as that, so plus 4.5, and then I'm going to run the 6 centimeters back. Okay, so that will go into my calculator. 4.5 plus 6 plus 4.5 plus 6 gives me an answer of 21. Now, because I've run a distance there, I would run that in centimeters, okay? For instance, if you think of Usain Bolt, he's famous for running the 100 meters, not the 100 meters squared. It's just the distance, okay? We wouldn't do anything else to that, okay? Volume would be centimeters cubed, but we're not asked for the volume. Okay, now have a quick read of question 6. Okay then. What you must do in an exam, even if you're unsure, is you must circle one of these. Lots of people don't even bother circling one of them, and you never know your luck. If they've given you 5 options, you may be correct. You've got a 1 in 5 chance of just guessing the right answer here. Now, you're expected to know this, that this angle here on the outside is the same as this angle plus this angle. So what I'm looking for is C is equal to A plus B, okay? Now here, we're told that A is equal to B plus C. That's not my option, okay? That's not true. This one here, B is equal to those two add together? No. B is equal to A minus C? No. C, there we go. Now this angle here is equal to those two there added together, and that's what it says, okay? And then this one here says it's C, which is that angle again, but it's take away that. That's not the case, okay? Okay, next question. It says A plus C plus S plus Q equals 360 degrees. So where's A and C? Can you highlight those? A plus C and then S plus Q. Okay, now S and Q have come up here. Now that angle there would actually be identical to this one because of what we call corresponding angles. So this is the same angle as S. D and S are the same size. And likewise here, Q could slide down what we call that transversal line, and this would be Q as well. So B is equivalent to Q. So this angle here, 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 and here add up to 360. Well, that's absolutely true because they're what we call angles at a point. So this is absolutely true, but if we just double check all the other ones as well, P plus A, so where's P? Here, and A, well, they are the same angles. They don't add up to 180 because they are the same. This is wrong. It would be true to say P equals A, but that's not what they're asking me to write down. C is equal to Q. Well, again, that's not true because they're not in the same place there. That Q is the same as angle B as the one down here. So that's not true. D is equal to R. Now, D is equal to S, and then S would be angles on a straight line. So I do 180 take away S to work out R. So very, very unlikely to be true, unless they're both 90 degrees. And then finally, P plus Q. So P plus Q, so these two here. So that's 180 because it's angles on a straight line. And then D plus C, that would be 180 as well, wouldn't it? P plus Q, yes. Yeah. Oh, yeah. Well, that's 180 plus 180 is 360, so it's not 180. So that's not true. Okay, so all the others weren't true as well. Okay, similar question down here. Now, again, you're expected to know some of these definitions. That's how some of these questions are very, very nice and easy and straightforward if you've learned them. We've got a pentagon here, and what they're looking at is what we call exterior angles. Now, they give me every single exterior angles, and there's a definition you should know that all exterior angles add up to 360. So literally the only option I'm looking for here is a plus b plus c plus d plus d equals 360, which is this one here. Okay, this one here is actually working out what each angle is worth. If you did 360, divided by 5 at all wouldn't do that. That's just a load of nonsense. 360 divided by 5 will tell you what each angle is. And this one here that says 540, that's telling you the amount of interior angles, that if A was here, B was here, C was here, D was here, E was there, they would add up to 540, but they don't because these are exterior angles. Okay, next question. Question number 7. Okay, so you will need a calculator for this one. There's a couple of different ways to tackle this question. I'll go through what I think is the most easy way. It says calculate the mean of these 4 time periods. Now, the thing you've got to be very, very careful here is 5 hours 20 is not written in your calculators as 5.20. Now, the reason why that is wrong is because decimals go up to like 0.8, 0.9. If it went to, there wouldn't be any 0.10. That's a really bad mathematical way of saying it. Effectively, once you went to 5.9, you would go to 6.0 because that 10 would come through into the units column. Now, minutes only go up to 60. Once I get to 60 minutes, I go into effectively 5 hours and 60 minutes would just be 6 hours. So you wouldn't use what we call decimals here. Okay. So what I'm going to do is I'm going to work out the total hours. So what I'm going to do is do 5 hours plus 2 hours plus 6 hours plus 4 hours. So 5 plus 2 plus 6 plus 4. Okay. That comes to 17 hours. The next thing I'm going to do is work out the total minutes. So 20 minutes, 44 minutes, 18 minutes, 34 minutes. So the total minutes, 20 plus 44 plus 18 plus 34. That's definitely going with the calculator, so I can't do that in my head. Comes to 116 minutes. Okay. Now, if I want to work out the mean time, what I need to do is I could either go and work out how many hours that is and add it onto there. But what I think I'm going to do is I'm going to work out the mean of the hours, the mean of the minutes, and then put those together. So the mean hours would be 17 hours divided by 4. So 17 divided by 4 gives me 4.25. Now be very careful here. 4.25 hours. 0.25 is the same as a quarter. So that is 4 1/4 hours. Now, if the time was 4:15, that would be 15 minutes past 4. So that's 4 hours and 15 minutes. This is what they're banking on you struggling with, okay? Now, if I work out the mean minutes, I would do 116 divided by 4. So 116 divided by 4 is 29 minutes. So my total mean would be the mean hours and the mean minutes. So it would be 4 hours, 15 minutes, plus 29 minutes. 15 minutes plus 29 minutes comes to 44 minutes. And not forgetting the 4 hours. Okay? A couple of different ways you could have done that. That's just the way that I decided to do it. Okay, have a quick read of question 8. Important thing to notice here is that in this question, you'll be assessed of your quality of your organisation, communication, and accuracy in your writing. Okay, have a quick minute to read the question. Okay then, so it says cube A and cuboid B are shown below. Express the volume of B as a percentage of the volume of A. You must show you're working. Now, the main thing to say here is that when you're told you'll be assessed to the quality of your written communication, etc., etc., that's only worth 2 marks. You've still got 4 marks for the maths. Okay, so there's 4 marks available for maths, 2 for making sure that you write it in an organised, well-written, communicative way. Okay, now in terms of one of the key things we're looking to give that mark there Just double checking the recording's caught up with me. Yes, it has. One of the key things we're looking at to give that mark there is that you always put in your units and they're correct. Okay, so a very easy way to make sure you're getting one of those 2 marks. To work out the volume of A, let's tell the examiner what we're doing. Volume A would equal 5 times 5 times 5. I could have said 5 cubed because it's a cube. Okay, so into my calculator goes 5 times 5 times 5. That's how you work out the volume, base times height times length. So I get 125, and I'm going to make sure that I say that's centimetres cubed because it's volume. Okay, now I want to work out the volume of B. That would equal 4 times 4 times 5. So again, goes into our calculator, 4 times 4 times 5. Okay, so that's 80. So that would be 80 centimetres cubed. Okay, now if I'm to do this bit here, express the volume of B as a percentage of the volume of A, they're looking for me to know a formula here, and you use this formula all the time to effectively work out what score you get in a test. So for instance, if I had a test and I got, say, 20 marks out of 25, I'd say, however many marks I got in my test, 20, out of the total marks, out of 25, and by the side, I'd times by 100. And I would have worked out that I had 80%. Well, this is the same idea. It says express volume B as a percentage of volume A. So volume B was 80 centimetres cubed. So I'm going to say 80 centimetres cubed, 80. It's fine, we don't need to put the centimetres cubed into this bit because we'll just work out a formula. Out of the total, so out of A, which was 125 centimetres cubed, and then times by 100. Okay, so that's going to go into my calculator. 80 out of 125, button to the side, times by 100, works out to be 64%. Okay, now I would then finish off by saying express volume B as a percentage of the volume of A. B is 64% of A's volume. Okay, what it's usually a good idea to do, there's no real sort of way here of saying it here, is I might just say an arrow pointing at any mass that's not really accounted for, which is maybe only this bit here. I'm saying everything else that I'm doing. I said this is a volume, that's how I'm working it out. Said it's centimetres cubed. I'd say using formula to work out percentage. So someone looking at my work knows what I'm doing there, okay? So a good rule of thumb with those type of questions. Okay, the next question, question number 9, says the diagram below shows an equilateral triangle. Now that's the key word here. Equilateral triangle means this side here that we're told is the same as this side, is the same as this side. Now because that's 4x minus 7, I can go and write that on every side because it is an equilateral triangle. So 4x minus 7 would go on every single side. Centimetres to be absolutely perfect, but you wouldn't necessarily need to write this in as a very final answer. It says the perimeter of the triangle is 27 centimetres. Calculate the value of x. So the perimeter means we do one full loop of that. Okay, so we go here, then here, and here. So we could say 4x minus 7 plus 4x minus 7 plus 4x minus 7 is equal to 27. That's absolutely fine. Or a quicker way to write that is say 3 lots of 4x minus 7 is equal to 27. Okay. The next thing I'm going to do is expand this bracket out to get 12x minus 21 is equal to 27. Now I'm going to start solving my equation, so very similar to like we've already done in the paper. So minus 21, we want to get the x by itself, get rid of anything not physically attached to it. The 12 is, get rid of minus 21 by adding 21 to each side. So we get 12x, those two effectively cancel out, equals 48. And then I want to get rid of that 12 that is touching the x, so I divide both sides by 12 to get x equals 4. Okay, I could say 4 centimetres. They wouldn't penalise me for a mark there because it's not an OCW question. Okay then, the next question says, a box contains many discs identical in shape and size. A picture of one of 4 Welsh castles is printed onto each disc. A disc is chosen at random from the box. Complete the table. Now, the thing that they expect you to realise here is that all probabilities must add up to 1. What I need to do is work out what 0.36 plus 0.12 plus 0.24 is. So that goes into my calculator. 0.36 plus 0.12 plus 0.24 comes to, as a decimal, 0.72. So what number would take that up to 1? So effectively I'm doing 1 take away 0.72. So 1 take away 0.72 would tell me that it is 0.28. Okay. Next one says, in the box there were 522 discs showing a picture of Caernarfon Castle. How many pictures, or how many discs show the picture of Harlech Castle? Now, this is quite a tricky question. This is easily the hardest one we've done so far. It says in the box, 522 discs was showing Caernarfon Castle. So you go and look to see where Caernarfon Castle is there, and we go and work out what its probability is. We know that we have a 0.36 probability would give us 522 discs, that 0.36 probability. What I want to do is work out how many had Harlech on there. So I don't want the answer to be 0.36, I want it to be 0.12. Now, there's a couple of ways you can do this. Some of you may spot the link between the 3/6 and the 1/2. That is 1/3 of it. So we could effectively divide both sides by 3, and that would tell us the answer. If you didn't spot that, if we divide both sides by 36, that will tell us what 0.01 is. Whatever I do to one side, I do to the other. So 522 divided by 36 gives us an answer of 14.5. And then to make 0.01 into 0.12, I would times that answer by 12. So effectively now timesing both sides by 12. So I do 14.5 times by 12 and get the answer 174. Okay, now the other way that's probably easier, but only if you spot it, is to say, well, if 0.36 probability is equal to 522, to get 0.12, I divide that by 3. And if I do 522 divided by 3 into my calculator, look, we get the same answer. We get 174. Okay, so it's whichever way you can spot. Okay, question 11 is quite a nice one, providing you've remembered your calculator. So this goes into calculator exactly as it looks. So it wants you to write it as a fraction. So I press the fraction button. So this one here, 145.3 goes on the top. Make sure that's correct. 145.3. I now press brackets and I do 12.4, take away 9.8, close the brackets, power button there, 3 equals. Now, the one thing you must do to get these 2 marks, write out the entire answer. Okay? We will get 1 mark for writing out the entire answer because we have effectively put that into our calculator correctly. Okay? And we're showing the examiner we've done that. Okay? Now, this is the bit to get the 2nd mark. To get 3 significant figures, we start counting after the first non-zero number. So here's my first non-zero number, 1, 2, 3. As soon as we started counting, we carried on anyway. Line would go down there. So that 6 would round that to a 7. 2 would go there, 0.8 there. Okay, so my answer to 3 significant figures is 8.27. The next one says the reciprocal. Now, it wants you to know what that word is. That's coming up more and more in the exams at the moment. Work out the reciprocal. Now, 47 is a whole number. Effectively, if I was to write that as a fraction, it would be 1. Okay? 47 divided by 1 is 47. A reciprocal is flipping the numerator and the denominator. So the reciprocal would equal 1 over 47. So into my calculator, I'm going to write 1 over 47, press equals, and it tells you it's 1 over 47. It wants it rounded to 4 decimal places. So I press SD, and then I'm going to write out the whole number again. So 0.021276595. 7.4. Okay, that'll definitely get me the 1 mark. To then get the next one 4 decimal places, well, there's a decimal point, first number after it, second, third, fourth. Line comes down here. That 7 will change that to a 3. We'll still have the 1, the 2, the 0, and that 0 would still be there as well. Okay, so to 4 decimal places, that would be my answer. Okay, the next one. Circle the correct answer. Which of the following values cannot be the external angle of a regular polygon? Now, for this to be the case, we've already discussed this in this video, that all external angles or exterior angles must add up to 360. So what I want to do is 360 divided by, in this case, 10. That would tell me that if I did have each exterior angle being 10 degrees, the polygon would have 36 sides. Okay, so that one works. Just put a tick next to it. You don't need to do that. It works. Okay. Divided by 18 equals 20. It would have 20 sides. 18 works as well. Divided by 30 equals 12. That one works. 48. Now this is telling me that my polygon would have 7.5 sides. You can't have a shape having 7.5 sides. It's either got 7 sides or 8 sides, not 7.5. It's this one because it cannot have that angle. If I divide it by 72, I'd expect to get a whole number again. So divided by 72 gives me 5. Okay, so again, that one works. That is my answer because all of those gave me whole numbers. That gave me 7.5 sides. That's a load of rubbish. Okay. Next question, 12b. It says, an arrow on a spinner is facing north. So let's draw it. That will help us work out what's going on. So facing north would be pointing straight up. And then we know to go a full spin around, we would go 360 degrees. It's turned clockwise, so it spins round 360, then another 360, then all the way until it's going 1530. In which direction will the arrow now be facing? So what we want to do is do our 1530 divided by 360 will tell us how many turns it makes. So into my calculator goes 1530 divided by 360. How many 360 spins fit into that? And I get the answer 4.25. 4.25 spins. So 4 full spins would get me back to north, and then I do a quarter spin. So that would be a quarter spin. So never eat shredded wheat. So my answer is it would be facing this way because it's quarter of a spin there. So my answer would be east. Okay. And then C is quite a challenging question, I thought. It was quite nasty. It says, point A is on a bearing of 100 degrees from point B. If it says from point B, draw point B. Here's B. There's north pointing upwards. An angle of 100 degrees. So there's 90 will come straight across here. So 100 is not far off at all. There. A is somewhere on this line. Okay. So I'm going to draw A as there. And north would be pointing straight up. Now this angle here is 100 degrees. We're told that from the question. Okay, now because these are parallel lines, because they are both pointing straight up for my north, we should know as mathematicians that these two angles are special. These two angles must add up to 180 degrees because of what is called co-interior angles. Okay, now to measure a bearing, I'm after what is this angle here, measured from north and clockwise. Okay, now I know angles at a point add up to 360. So 360, take away the 80 I've already accounted for, would tell me what this angle here is. This angle is 280 degrees, so it's that one there. Okay. Okay, nearly missed a question there. Question 13, trial and improvement question, okay? Now, to do this, you'll want to draw a table and you'll need to record a lot of results as you're doing it, okay? Now, I always do my a table with 3 columns, a column with 3 tables. The 2 end ones are really skinny. The one in the middle is really big. And the reason why it's really big is because I'm going to show lots of working in there. Okay. Here goes x equals, here is my equation. So my equation is this thing here. X cubed minus 7x minus 51 equals 0. And here is a comment. Okay. So the first thing I do is I always try the numbers it tells me in the question. I will get 1 mark for trying 4 and 5 there, and also it will confirm if it does lie between 4 and 5. Now this is the best way to do it in your calculator. I've talked about it once already. Wherever you see an x, you change it for open brackets. Okay, so far just open brackets cubed, minus 7 open brackets, minus 51. Now if I press equals, it'll just tell me syntax error. And that's because numbers need to be inside the bracket. My first number that I'm trying is 4, so inside the bracket goes 4, inside both of them. Okay, I get the answer for 4. Now, I'd show this in the real exam, not minus 4, sorry, I don't know where that came from. I would show every single answer that I do in the exam here, okay? So minus 15, I'm supposed to get 0, that is in the negative, so it's too small, TS for too small, okay? I now change that to a 5, and it should be positive. It should be bigger than 0 this time. I press equals, and I get the answer 39. Okay, so 5 cubed minus 7 lots of 5 minus 51 equals 39. Okay, now, the best place to go next, if you're ever unsure, the best place to go is bang in the middle. Okay, you could just go to 4.5 here. Now, 4.5, you then start to work out where to go for the next. But I'm going to try and use a little bit of logic here. I'm trying to get 0. If we look at a number line and put 0 in the middle, if minus 15 is there, 39 has got to be further away. That is only 15 away. That is 39 away, okay? So it's definitely closer to this answer of being 4 here. So I'm actually going to try, save myself a little bit of work. I'm going to try 4.3 because I think it's got to be closer to 4, okay? So 4.3 cubed minus 7 lots of 4.3 minus 51 is equal to. Now that goes into my calculator. Never press on, never press AC. You just use your replay button to cycle through there and put in the new number. So not 5, we delete the 5, change it to 4.3 in both cases. I get the answer minus 1.593. So minus 1.593 goes in there. That is too small, it's negative. TS for too small. So I now try a bigger number. Now be careful. When you try a bigger number, you must go in what we call consecutive numbers. So what is the next logical number after 3, 4, after 4, 5, after 5, 6? They've got to be in what we call the counting numbers, okay? Consecutive numbers. If you skip any numbers now, you run the danger of missing marks in the exam, okay? So now I'm going to try 4.4. So put 4.4 cubed minus 7 lots of 4.4 minus 51. And because I've got it all set up in my calculator, it's very easy now. All I do is delete the 3, change it to a 4. Okie doke. I get 3.384, which is too big. Okay. Now, we are very nearly there. Because it's gone too small here, then too big here, it is between these two guys here. I've got to choose which one is closer to 0. Now, I can sort of tell. Okay, I can sort of tell which one's closer to 0 because minus 1.593 and 3.34 I could picture like that. But what I must do in the exam is I must show that I've looked at this logically. So I'm going to try and draw this in a diagram and show you what I'm doing, okay? I've tried 4.3 and my answer was too small, so I try a bigger number. I've tried 4.4 and that was too big, which tells me to try a smaller number. What I'm going to do is cut this line precisely in half. So what number is in the middle of 4.3 and 4.4? The answer being 4.35. So I'm going to try 4.35 and see what I get. So 4.35 cubed minus 7 lots of 4.35 minus 51. So again, using my calculator, all the hard work is already done. Delete the 4 and change it to 35 in both brackets. And I get the answer 0.862 blah blah blah, which is positive, so it's too big. That answer is too big, so I must try a smaller number. If I must try a smaller number, I've got to be somewhere in between here. So am I closer to 4.3 or 4.4? I am closer to 4.3. If you find that explanation difficult, which one is the odd one out here? Too small, too big, too big. Which one is the odd one out? That one. That's your answer. You must finish by stating that x is equal to 4.3 to get your final mark. Okay, the next question. I thought this was a bit of a sly question for quite a lot of work for not a lot of marks. The highest common factor of 30 and 75 is the square root of a number. What is the number? Well, I need to work out what the highest common factor of 30 and 75 is. Highest common factor, I'm expected to write all the numbers of times together to make these two numbers. Now, there's two ways I could do it. I could do 30, and I could work out all the numbers that times together to make 30. So 1 times 30, 2 times 15, 3 times 10, 5 times 6. Okay, the next one would be 6 times 5. I'd start repeating myself. No more need to do that. But I'm caused a bit of a problem if I try and do it this way with 75. I know 1 times 75 would make it. 2 doesn't make it. 3 could make it. So let's use the calculator. 75 divided by 3 gives me 25. So 3 times 25. 4 doesn't because it's an odd number. Does 5? Well, it ends in 5, so it must do. 15. 6 doesn't because it's even. 7, it's not in the 7 times table. 8, no, it's even. 9, let's just double check it. 75 times by 9. No, it doesn't. It gives me a fractional answer. The next one is 10. No, it doesn't. 75 divided by 10 doesn't end in 0. Doesn't go to 11, 12, 13, 14, 15. No, so that's all of my numbers. Now, what I could have done instead is I could have done some factor trees and said, well, that's 3 times 10. That's 2 times 5. And then done the same for 75. That is 25 times 3. That's 5 times 5. And then done 2 Venn diagrams, or 2 circles as Venn diagrams. 3 is in both lists, so 3 goes in the middle. 5 is in both lists, so 5 goes in the middle. On the 30 side, I've got a 2 left. On the 75, I've got a 5 left. And the highest common factor is this number here times this number here, so 3 times 5, which would be 50. Okay. Alternatively, if I did the lists, what's the highest number that's in both lists? 15. There's also a 1. There's also a 3. There's also a 5. But the highest common factor, the highest one that's actually done, is 50. The highest one that's highlighted is in both lists. Now, we're told, not that to find the highest common factor, we're told that the highest common factor is the square root of a number. So we're told that something square rooted is equal to 15. Okay, well, to work out what that is, I need to square both sides. So I need to do 15 squared. So that can go into my calculator. 15 squared is 225. So x equals 225. Okay. The next question, again, is sort of banking on you understanding your percentages, decimals, and all of those. So it says the cube root of a number is 32.768. The cube root is 33 1/3%. So what I need to do is work out what the cube root of 32.768 is. Okay. So on my calculator, I'm going to press Shift and the square root button, and the little cube root comes up there. 32.768 comes to 3.2. Okay. Now, in terms of what we're told that 33 1/3% is equal to 3.2. Okay. The cube root of this, which is 3.2, is 33 1/3% of a number. What is the number? Well, the number would be 100%. So what do I times 33 1/3 by to make it 100? The answer would be 3. This is equivalent to a third. So a third to make a whole would be 3/3. So I times both sides by 3. 3.2 times by 3 would be 9.6. Okay? Have a quick read of that question. Okay, so it says PQR is a right angle triangle shown below. PQ, and they put all these numbers into the picture for you. Calculate the length of QR. Now, we've got two sides given. We're looking for a third side. There are no angles in here other than the right angle. This is a Pythagoras question. Opposite the right angle is the hypotenuse. The hypotenuse is the side I'm trying to find, which is QR, Q to R. So in this case, I want to do 0.89 squared plus 1.41 squared to get QR squared. Okay, now that line is literally just going to go into my calculator. That's all that I'm going to do in one go here. 0.89 squared plus 4.41 squared is equal to, and that goes into my or onto my sheet. So I'll get a mark for writing this. Now, the next thing I want to do is not have that as squared. I want to unlock the squared, so the opposite of squaring is square rooting. So I'm going to square root 2.7802. So square root 2.7802 equals. Now, because that's quite a long decimal, what I could do for 1 mark is I could just try to make sure I get it, is to write it out. It doesn't actually tell me anywhere to round that, so technically that should give me the full 3 marks. Because that's 2 decimal places and that's 2 decimal places, I would probably round it to 2 decimal places as well, which would be 1.67 meters is equal to QR. Okay? Over the page, what have we got? Okay. Visitors on the top of Snowdon can either walk up the mountain or take the mountain railway from Llanberis. On a particular day, a visitor to the top of Snowdon is chosen at random. The probability that the person is female is 0.42. Well, that means that the probability of being a male must add to 1, so that would be 0.58. Okay, those two numbers there would add up to 1. If you're in doubt, the best way to do it is literally to do 1, take away 0.42, or whatever probability you're given here, press SD, and it will tell you what that one will be there as a decimal. We're then told the probability that the person took the train is 0.35. So probability the person took the train is 0.35. 0.35 will go there as well for the males. And we're then told that the decision to walk or take the train is independent of the gender. So that means they're not affected, okay? So that means I can write it in both of those. I now need to work out what the probability of someone walking is. So that would just be 1 take away 0.35. So that would be 0.65. So I think I get 2 marks, so just 3 marks for filling in the probability tree. Lovely. Lovely 3 marks there. Okay. We're then told the person is chosen at random receives a gift voucher. What is the probability that the person is female and travelled up by train? Okay. Well, female travelled up by train would be that path there. What you must do for that path is multiply the probabilities together. So it would be 0.42 times by 0.35. So that goes into your calculator. Make sure you can see that, sorry. Put that down. 0.42 times 0.35 is 0.147. Okay. Over the page, question number 17. Says the diagram shows 2 similar shapes. Now, similar is the key word here, okay? Similar means that this has just been stretched and it is exactly the same in dimensions. They're just bigger. One's bigger, one's smaller. So this one's the smaller one, this one's the bigger one. Now, what I need to do is work out how many times bigger the bigger one is. So what I do is I look for what we call corresponding sides where we know both the sides. Now, here, I've got 3.2 and an x, so that's no good. Here, I've got 5.6 and 8.4. I know both of those. So I can use that to find what we call the scale factor, how many times bigger it has actually got. Okay. Now, to work that out, I always do the big number, 8.4, divided by the small number, or the smaller number. Okay. So 8.4 divided by 5.6 gives me an answer of So let me make sure that's 8.4. 3 over 2, which is 1.5. 1.5 is what we call the scale factor. Scale factor equals 1.5. It's 1.5 times bigger. So I am timesing this smaller one by 1.5 to make the big one. And to work backwards, I am dividing by 1.5. Okay? Now, to work out x, here, I look for its corresponding side. Here, which is on the smaller one. To go from the smaller one to the bigger one, I would times by 1.5. So I do 3.2 times by 1.5. That would go into the calculator and gives me an answer of 4.8. Okay, I would just state for me x equals 4.8 centimetres. Okay, to go and work out y, we've already done all the hard work. Where's y? There. What's its corresponding side? This one here. I'm on the big one, I've got to get to the smaller one, so I'm dividing by 1.5. Okay, so I need to do 6.3 divided by 1.5. That goes into my calculator, and I get the answer 4.2. So 4.2 y equals 4.2 centimetres. Okay. Question C is related to this. It says, explain clearly why the following statement cannot be true. CD, so that's this line here, and the length of RS, so this one here, so they are corresponding, is 6.5. Explain clearly why the following statement cannot be true. Okay, well, if we do the bigger one, 6.5 divided by the smaller one, we should get 1.5. That's the scale factor. So 6.5 divided by, 3.9 is equal to not 1.5, but 1.6 reoccurring. So as the corresponding sides, or as the scale factor is 1.5, these corresponding sides must also have the same scale factor. Okay, that would be my answer for that one. Okay, really long paper, this one. What we know, 57 minutes. These usually last me about 50 minutes, so this is a long one, okay? It's not been an easy one by any stretch of the imagination. Okay, so we are told that the length of the rectangle, so all this information is put in here, although what they haven't told me is that's equal to 72 centimetres squared. And then a kite, so this side here will be the same as this side here, so that must be 3x centimetres as well, and this side here must be the same here, so that's y centimetres as well. And we're told the perimeter of that. Now, I know the area, I would do 12 times by 2x minus y would give me 72. Now, I can get rid of that times by 12 very easily here. I'm going to divide both sides by 12, which will cancel those two there, leaving no need for the bracket now because there's nothing being done to that bracket. 2x minus y equals 6. Similarly here, I know the perimeter would be equal to all of these sides added together. So it would be 3x add 3x, add y, and that would be equal to 33 centimetres. So I can make another statement here. 6x, 3x plus 3x, plus 2y would be equal to 33. Okay, this is effectively simultaneous equations now. Now, the fact that we're right at the end of the intermediate paper and that it's got an x and a y, it should be giving you a bit of a hint this is simultaneous equations. I'm going to go and write those two equations a bit more neatly down here now. Equation number 1, 2x minus y is equal to 6. Equation number 2, 6x plus 2y is equal to 33. Now, if the signs are ever different here, I would always get these two things the same and add the equation. So I'm going to get them the same by timesing this one by 2 and timesing this one by 1 effectively, okay? I'm going to get two new equations doing that, equation 3 and 4. I'm going to get 2x times 2, which is 4x, minus y times 2, which is minus 2y, and then 6 times 2, which is 12. To times everything by 1, it will remain the same effectively. It's exactly the same. Equation 4 and equation 2 are the same. Okay. Now, if you ever get two signs that say two of the different signs there, and these two numbers are the same, if we add them together, you get 4x add 6x, that give me 10x. Minus 2a, 2y, add 2y would cancel out. They effectively cancel out. And then 12 plus 33 give me 45. To then work out what x is, I would divide both sides by 10. So x is equal to 4.5. Now this value of x will go into one of our two original equations, 1 or 2. Don't ever choose one with a negative, it'll make your life harder. So I'm going to choose number 2. Okay, so coming over onto my continuation page, I'm going to say sub x equals 4.5 in 2. Okay, so that's going to be 6 lots of x, so 6 lots of 4.5 plus 2y is equal to 33. 6 brackets 4.5. What's that equal? 27. 27 plus 2y equals 33. Get the 2y by itself by getting rid of anything that's not physically attached. Take 27 off both sides. Leaves me with just 2y here. Leaves me with 6 there. And then get rid of the 2 times in the y. So divide both sides by 2 to get y is equal to 3. Okay? Final question. Question A. It says, calculate the value of x. So x is this shape here. Now, you need to try and spot triangles that are going on here. So because of this angle here being x, I'm looking specifically at this right angle triangle here. Okay? Now, this right angle triangle here has got 2 sides that I know and an angle I'm trying to find other than the 90. So this is telling me to use SOHCAHTOA, which is trigonometry. It's the last question. It makes sense. It's here. Okay. Now that angle here, this is opposite that angle. Okay. This side here is touching that angle, so it is the adjacent. Okay. Now in terms of SOHCAHTOA, I have got the opposite side and the adjacent side. So what I do is cross those off my list of SOHCAHTOA. The one that's doubled out is the one that I'm looking for. Okay. Now what that's telling me, TOA tells me tan angle, which I don't know, it's angle x. So tan x is equal to the opposite side, 6.5, divided by the adjacent side, divided by 10.4. I now want to get the x by itself. To get rid of the tan, I do something special with the tan. I do the inverse of tan, which is tan minus 1. I now get tan minus 1, which will bring up a bracket, and I'll do 6.5 divided by 10.4. That goes into my calculator by pressing shift and tan first. So shift and tan, 6.5, 10.4. Press equals, and I get the answer 32.0 degrees to 1 decimal place. Okay, so this angle here is 32 degrees. Not 32.0 now, just 32, because 32.0 is 32. Okay, now the next thing they've asked me for, which is probably on the very last page here, there, says, hence find the length of DE. So DE is this side here. Okay, now this side here is also within a right angle triangle. Now I know 9.4 is the hypotenuse of this right angle triangle in yellow, and now I know all of this angle here, 32 and 22, would be 54 degrees. I want to go and find the side that is opposite that angle there, that one that encompasses both the 32 and the 22. So again, I'm going to write SOHCAHTOA. That's the hypotenuse. Now this this side here, the DE side, that is opposite that angle. Okay, so the adjacent, just highlight that in green. That's the green side. This op is the DE, is this side here in yellow. Okay. Now I want to find that. I know that The adjacent side I'm not given and I'm not asked for. Okay, so I'm going to go and cross off from SOHCAHTOA O's and H's. So O's and H's. The one that is double crossed, I'm going to use. That's S, which stands for sine. So that would be sine angle. So the sine of the angle would be the whole total angle for that right angle triangle, which is 54, not 32 or 22, 54, which is both of them. So it'd be sine 54 is equal to the opposite side, which we don't know. So I'll just write op divided by the hypotenuse side, which is 9.4. To get rid of a divide by 9.4, I'm going to times both sides by 9.4. And that will tell me what the opposite side is. Effectively, those two there will cancel out, leaving me the opposite. So I say sine 54 times by 9.4. Okay, make sure the brackets come around the end there. Automatically, when I press sine, it automatically brings up a bracket. So I must close that bracket off the angle, times by 9.4. Okay, I get the answer. Again, I could write the whole thing out if I wanted to. Might just round that to one decimal place nice and early because everything else is in 1 dp. But I must state if I'm rounding, okay? If that was useful, thank you very much for watching. If that was useful, please could you press the subscribe button. Thank you very much.